Hello, and thank you for joining us for our database troubleshooting webinar. I'm Grant Swanson, and I'll be your host for the session. And we'll be joined by the VP of Product Marketing, Kevin Leong, and our Senior Director of Product Management, Rakesh Gupta. Welcome, Kevin. Welcome, Rakesh.
Thanks, Brent.
Thanks for having us.
All right. Hey, welcome everyone. I'll kick it off first to share a little bit about Observe, and then I'll turn it over to Rakesh, who oversees APM here at Observe, and he'll tell us more about the latest in APM and how we can be troubleshooting database performance. So for those of you, maybe you have some familiarity with Observe or perhaps not. But I thought it might be a good idea to give folks an update on what Observe is all about. So Observe is a modern observability platform engineered for scale. What we've done is we've built it from the start for performance, to enable faster troubleshooting, and to be cost efficient at large scale. And really here, there's several things that we've done differently to allow us to do this. On the performance front, Observe uses a real-time ingest pipeline that can handle petabyte per day ingest, as well as a knowledge graph that structures the telemetry for fast search and correlation across logs, metrics, traces. We actually won't go in depth in today's webinar on these performance concepts, but suffice it to say, Observe has built quite a few enhancements to provide good user experience when analyzing and querying telemetry in Observe. On troubleshooting and investigation, Observe has multiple explorers that allow users to analyze their telemetry that's in Observe, whether it's log analytics, infra monitoring, or APM. And actually, a newer way to analyze data in Observe is through the Ollie AI Investigator, which you can see up top, which allows engineering teams to use natural language in chat-based interactions, coupled with an in-depth knowledge of their systems that the investigator has. And the goal here is to help users resolve complex incidents faster. And I think you'll see that all this is built on a data lake foundation, which is the most cost-effective way to store telemetry at scale. Most of our customers typically choose to go with Observe because of performance, because we can help them lower their MTTR, because they're able to store the telemetry they need at much lower cost without compromising the visibility that they need in the systems. So that's really Observe in a nutshell. And I'll turn it over to Rakesh to tell us more about APM and the latest.
Sounds great. Thanks, Kevin. So we just went over the architecture and the platform of Observe and talked a lot about scale and efficiency and open data collection. And so that has informed our perspective on application monitoring. So I wanted to talk a bit about what our approach is there. So as Kevin mentioned, Observe is built on open standards, open data collection, and that's no different for APM. So all of the data that powers our APM product is open telemetry data. So the data you get when you instrument your applications is what our APM is built on. And so I have worked at a couple of APM companies in the past with proprietary agents, and they all had a very slick ease of use, just like getting the data in. And now with OTel, we've seen a lot of maturity in the last year or so with things like the auto instrumentation and the zero code for a lot of the common languages that are allowing us to really leverage open telemetry for the data collection for APM and not have to build proprietary agents. And then, of course, all this data is getting sent to the platform, which Kevin went into a little bit of detail talking about. So lots of capabilities there that allow us to ingest data at scale, store it very efficiently, and do all sorts of really interesting computation on it. and basically provide APM at a high scale and at high efficiency. And then, taking all of these platform advantages, again, as Kevin mentioned, the top layer of the architecture is our explorers are basically easy to use workflows for consuming all of the data. So with APM, there are APM, you can think of it as kind of like a big toolbox with a bunch of tools in it, and each tool you pick up when you have a specific problem, like the code is slow, or you're having errors, or the database, as we'll talk about today, is causing latency. And so in our product, through all the different explorers, there's just different tools in the toolbox that allow you to very easily go through your application data and understand what's actually going on, so you can get to the root cause. So what does this actually translate to? Like, what are the specific capabilities of Observe APM? So as I mentioned, it's fully open telemetry native. All of the features that are available in our APM are powered exclusively by open telemetry data that you can get using the open source OTel libraries. Our product by default offers 13 months of retention for your traces, and at 100%, so there isn't any sampling. Now you can of course configure sampling if you like, but by default we store 100% of the data. So this would be in contrast to other products that store the data for like 8 days, or even sometimes as little as 15 minutes before starting to drop it. Because we're built on a data lake architecture, we can store data much more economically for much longer periods of time. And then, of course, application monitoring is driven by metrics. So you want to know how your service is performing. Is it slow? What's the latency of it? How many errors are you getting? What's the throughput? So we provide red metrics right out of the box for all of your OTel instrumented services. And then we do automated service discovery. So you go into our service catalog and you can see the list of all the services that we have discovered from your OTel data, basically using the service tag on the OTel data. And we also look at the dependency relationships, and we build a dependency map of all of your services and databases as well. So what's communicating to what? So that is also provided out of the box when you send in your OTel data to us. And then, so that's the kind of monitoring capabilities. Now, going a little bit deeper into the service troubleshooting, there are a number of capabilities that Observe has around inspecting services. So service dashboards out of the box with not only the red metrics, but also latency histograms and distribution charts to help you understand the shape of your services performance, as well as latency breakdown charts that help you understand where the time is being spent. So if it's being spent in the service itself doing computation, or if it's spent in the database, or if it's spent in a downstream service or a dependency that you're calling, we'll be able to provide that with the visibility into that with the time spent chart. And we also provide deployment markers. So if you're launching a new version of your service, you just enter that in your OTel span attributes, and we surface that as a marker on a chart so you can correlate a spike in latency or errors with a new deploy. We also provide error tracking out of the box, again, powered by the OTel span event data. So being able to aggregate and inspect errors and exceptions, and look at the stack traces. And then lastly, for individual traces, we have a couple of different visualizations for those to help you understand what's actually going on in the life cycle of a request. And that would be our flame chart as well as our waterfall view, which you can see here. So that's the kind of broad overview of our capabilities with Observe APM. And now I wanted to talk a bit about what we're gonna be showing you today, how you can do this and observe is we'll talk a little bit about the N+1 query problem. So what basically is this? Is that so when we were developing our Observe APM, we talked to a bunch of customers and we said, hey, what are the problems that you're facing in your applications today? Like what's hard for you? And the overwhelming answer was, hey, I have an N+1 issue, or I have some kind of database slowness. Like my service depends on a database, and the database is hosed, and it's hard to go from, hey, I see this slowness in my metrics to it's actually a database issue. And I had heard about this, this particular use case before, and knew that there were customers that were struggling with this. But I was honestly kind of shocked that in the year 2025, this is still a very prevalent problem. But it turns out that it is. And specifically what customers say is the a specific type of database problem that they have is the N+1 query problem. So what is that basically? A simple example of an N+1 problem is where, let's say you're an e-commerce site and one of your services returns back a list of all the products that are currently available. So you can give it to the front end, so the front end can list out all of the different products so the user can browse what you have for sale. And instead of making, let's say you have 100 products, and instead of making a single database call with all the product IDs to go and retrieve their details, the code instead has a big for loop in it where you go for each product that you have, call the database and go get its information based on its product ID. So what you've effectively done there is you have made 100 database calls, and instead of having a single database call with all 100 product IDs in it, so you're getting it all at once. And it's a very common problem. Again, I was kind of surprised like how prevalent it is, but it's something that a lot of folks are struggling with. And one of the things that customers were saying is that it's kind of sneaky because it seems to work in testing environments under low load, and that things are slowing down. It's only when you launch it in production and you have production level traffic and load on it that you start to see that the performance is starting to degrade. You first start to notice it in the red metrics for your service. The latency starts to creep up. And what customers say is that it's actually kind of hard to look at the metrics and go from there into the traces to really figure out what's actually going on. It's almost like searching for a needle in a haystack. And this is the thing that folks are struggling with. So this is kind of setting the stage for what we wanted to demo today, how you can solve this problem in Observe. So we took all of this customer feedback and we basically built out our APM to make sure that we put a bunch of capabilities in, as we'll see, to make sure that we could solve this problem. So now now we've kind of set the stage here. Let's go into a demo and show you how you can actually solve this problem in Observe. So I'm going to be using the Hotel demo app for this, and you may be familiar with it, but just in case you're not familiar, it's an e-commerce site where it basically has a bunch of astronomy related things that you can buy. So you can browse this site. You can add things to your cart. So we'll go ahead here and add a couple of things. Uh, let's build out our cart here. And so now you can add in when you're ready to check out, you just go ahead and enter your details and then place an order. So fairly straightforward. It's built on a microservices architecture. So there's a microservice for the front end. It's a next.js app. There is a microservice for the product catalog, for the inventory, for sending out this confirmation email. There's a microservice for checkout, and they're all just basically communicating with each other using gRPC over HTTP. So that's the kind of overview of this app that we're going to be using today. So now the scenario is basically, so let's go into Observe here. Let's say you're an on-call engineer. You work at this company that makes this e-commerce app, and you have started to receive reports, and also you've got an alert that the service is, or that the app is kind of slow, that users are struggling to check out. You can kind of see in your alerts for the checkout service that there is abnormal latency going on. And so it's kind of illustrating to you that, there's some kind of problem, and you're on call. And this is a big problem, especially with a service like checkout, because if folks cannot check out, then they cannot transact with your business, which means that your revenue can be impacted. So it's quite an urgent situation to figure out what's actually going on here. So let's say, so you're that on-call engineer. You come into the service catalog here, and you go and select the checkout service, because that's the one that you're getting the reports on. That's the one that your errors, sorry, your latency alerts are actually being generated on. So let's go and inspect this checkout service. So when we go and inspect it, we see a few things. So the first thing is the latency histogram here. We've got a few outliers, like requests that are taking much longer than normal. And we also have a performance breakdown chart, this very large chart here that basically illustrates the latency over time. And we can see that definitely in the last 5-10 minutes or so, the latency has started to spike. And this is something that gives us our initial clue, like, okay, something was normal before, and now it's spiking. So what is actually going on here? So we can hover over this breakdown chart, and will actually tell us that where the time is being spent every minute, that the time is actually not being spent inside the service, inside the checkout service itself. It's not really being spent in any database call. It's actually a call to some external service that this service depends on is actually the culprit here. And we can go and actually see which service it is that is calling. And we can see here that when we select this downstream service breakdown, that it's actually the cart service that the checkout service depends on, that suddenly the latency of the calls to that service have spiked. So that's now giving a clue that the checkout service is slow, but it's actually not because of the checkout service itself. It's because of the cart service that we call. So what we do now is we go straight to the dependency map, and we can see all the services that the checkout service calls. And we see the cart service here. So we can we can inspect the cart service straight from there. And now we are opening the dashboard for the cart service. And we see that a similar story, that we've got some outliers here on the latency histogram, but we also have in our time spent chart for the cart service, we have some latency spike as well, and roughly the same time that the checkout service had its spike. So now when we hover over the time spent chart for this service, we see that the time spent is actually inside the database. So the cart service is making a call to the Redis database. And that used to be very quick, as we can see, but now it's taking much more time. And the bulk of the time being spent in the cart service is actually being spent waiting for Redis. So now we've got a bit more of a clue. We're starting to narrow down what's actually going on here. The next thing that I might want to look at is are all of so the cart service exposes a bunch of endpoints to the checkout service. Is it all of those endpoints that is causing an issue, a latency issue, or is it just some subset of them? Because if I can narrow it down to a single endpoint, that's basically a single code path that is very easy for me to then go in and check what's actually going on. So that will help me narrow it down further if I can. So I'm going to go to the endpoints breakdown here for this time period. And we see that there are 3 endpoints in this service: empty cart, add item, and get cart. And what we see in the breakdown of latency over time is that indeed only one of these endpoints has experienced a spike in latency, which is the empty cart endpoint. Now, as an on-call engineer, I may or may not know that the checkout service, when you actually make a call to check out, it'll go and empty the cart, and it needs to do that before actually processing the transaction. But you don't actually need to know that, as we'll see. We can just kind of follow the clues here. So I see that empty cart has spiked. So now what I'm going to do is I'm going to filter my cart service dashboard to just the empty cart endpoint and see what's going on with that, because that's clearly where the smoke is coming from. So let's go into the empty cart endpoint. Now we pull up this endpoint inspection kind of fly out dashboard so we can go and take a look at this more deeply. This endpoint also has a time spent chart, and we can see that that this is the endpoint that is making the calls to Redis. So a lot of the time being spent when you make a call to this endpoint, almost all of it is actually spent inside Redis. And we can go and drill down even further into this chart and see that it's specifically this operation called LREM, like a remove operation in Redis, that is causing the bulk of the latency. So now I've gone from, so to recap it a bit, I've gone from the checkout service was slow to actually the checkout service calls the cart service and the cart service is slow to actually the cart service, only one endpoint is slow, which is the empty cart. And actually the empty cart endpoint is slow because it's making a database call. And actually that database call is an LREM. So now I've really narrowed down the blast radius here very quickly. Now I want to start looking at traces. So if I had started looking at traces earlier, I might be again looking for a needle in a haystack, which is what our customers were struggling with. I've really localized the problem. So let's go and take a look at the traces tab inside this flyout dashboard here. And you can see that it's automatically filtered to the slowest traces. And it's surfaced just 3 examples of slow traces. Without knowing anything further about selecting which trace, I'm just going to do the naive thing and just click on the very first trace here. And start to see what's going on. So this is a trace that we can see its waterfall view, and we can see the flow of service calls. So we had a trace that originated from a request that originated from checkout. It called the cart service, and inside the cart service, we see all of these LREM operations, and each of them is taking 100 milliseconds, but I'm making a bunch of them. They're starting to add up. So this is a classic symptom of an N+1 problem where you can almost visualize it just by looking at this waterfall view, that in the code there is some for loop that is going on where each iteration of the for loop, an LRM call is being made. And we can test this hypothesis further by inspecting each of these LRM calls and looking at actually the line of code that was causing the issue, the specific database statement that was made as part of that call. And we can see it's removing a cart, an item from the cart with a specific ID. And we can go through each of these LREMs and look at the database statement and very quickly see that it's a different ID that's being emptied. So it gives a lot of evidence that what's going on here is that the user had 10 items in their cart, and when they're checking out, it's deleting each of the items one by one in separate database calls. So now I have enough information to basically conclude my investigation. I'm done essentially with Observe at this point. I can go into the cart service, into the empty cart endpoint, and go and look at that code and basically see that that there is a for loop or some kind of a loop there where I'm calling the database 10 times and just rewrite that database query so that it's only making one database call for all of the IDs that I get for this particular user's cart and just and ship that code, and then we should start to see an improvement here. So recapping all of that at a very high level, we started with reports that the checkout service was slow, and the alerts went off that there was abnormal latency in the checkout service. And we took this journey in just a few minutes to isolate the issue to a downstream service that calls a database that has an N+1 issue. And we were able to rapidly get to what is the actual root cause of this latency. So that's the demo that I wanted to show you. So really excited to get folks using this and and get this into the wild. And we just released this about a month ago. So if you're an Observe customer, you have this available. And if you're a new customer if you're signing up for a free trial, or you're just getting started with Observe, you'll be able to start using this.
Excellent. Thank you, Rakesh. That was a great demo. For everybody on the session today, if you have questions, I see a few coming in. Please punch them into the Q&A window. So Rakesh, I have the first question here is, how does this workflow scale beyond the demo app? What if we have hundreds of microservices?
Yeah, that's a good question. We have a few customers who are at a very high scale. So they have dozens, or I've even seen, I think, like several hundred microservices. And this is one of the things that other products sometimes struggle with, is just loading in all of that data and even just rendering it in a service map. But this workflow is actually even more valuable at that scale, because without that service map that basically helps you go from the checkout service to the cart service downstream, you kind of have to look at each downstream service separately. You just have to line up, do some manual correlation. And if you have 100 services, that's really difficult. But with that time spent chart and with the dependency map, it's very easy to go straight from your service that has the issue to the downstream dependency that is actually where the root cause is. So it improves it becomes more useful at higher scale.
Excellent. The next question that just came in, what data do I need to collect from my application to use this workflow? And how can I collect that data?
Yeah, so as I mentioned, we're OpenTelemetry native, and so all of the data that you saw today that we were going through just comes straight from the OTel instrumentation. And how to collect that data. So we have on our docs site, I'll go and show you how easy it is to get started. So let's say you have a Java service. You just run this command and you set these environment variables, and then you're collecting all the data that you need to power this use case. For a different service, let's take or a different language for Node, it's very similar. You just run a couple commands. You're just getting the OTel libraries. You set a couple of environment variables, and you're basically off to the races.
All right, thank you so much. We've got one more question that came in. If you have other questions, we still have a few minutes left. One issue we face is the database query is sampled out and we can't get to the root cause. How does Observe handle this?
Yeah, so this is a common thing that we heard at our customers as well, and a lot of it is driven by just the economics. That it's really hard to store all the data that you need. You don't know what data you're going to need in an incident, and this is one of the reasons why we were built originally on the data lake architecture, as Kevin described, because it allows us to much more economically store all of the data that you need, whether that incident happens 15 minutes or an hour later, or you're doing some kind of post hoc analysis, 30 days later. That all said, you can still sample in the platform if you want, and the sampling approach that we recommend is tail sampling, which is sampling at the trace level rather than at the individual span level. So you won't get into a situation where you get a report that the service is slow, but then you're actually missing the database calls. So every trace that is sampled in that we actually receive, it will have all of the full fidelity information under that sampling protocol, or that sampling mechanism, which we recommend. And that's all in our documentation, and our Observe agent fully supports that type of sampling as well.
Excellent. Thank you, Rakesh. For everybody on the call today, like Rakesh had mentioned earlier, if you go to www.observeinc.com, we have a free trial available. I just also inserted the most recent blog that's related to this webinar into the chat. Additionally, everyone who registered for the webinar will get a recording. And we appreciate everybody for joining us today, and this will conclude our session. Thank you so much.